Hi, this is Nathan.
And I'm Rami.
And this is CALC Busters.
Along with our sidekick, Jenny.
In this episode, we're testing
Gabriel's horn.
and the sum of all natural numbers. Let's go at that random bystander about our myth. Do you think the sum of all natural numbers is equal to infinity?
No, dude. Like, what are you doing?
Do you think something can have finite volume but infinite surface area?
Sure, I guess.
Okay, bye.
The first myth is, can something have finite volume and infinite surface area? We will test this myth out by using the function f of x is equal to 1 over x with the domain 1 to infinity. We will plug in 1 over x into f of x and square it. And that will be from 1 to infinity. We replace infinity with b by setting the limit as b goes to infinity. Then you do the antiderivative. This will give you pi times the limit as b approaches infinity of negative 1 over x from 1 to b. Then you plug in b and 1 for x. This will give you pi times the limit as b goes to infinity of negative 1 over b minus negative 1 over 1. Then pi times 0 minus negative 1, which will just give you pi. And this means that it is finite. And now Shanit will do the surface area.
Next we'll be finding the surface area of 1 over x with its domain being from 1 to infinity, and this is the equation for surface area right here. We get 2 pi times the integral of 1 to infinity of 1 over x times the square root of 1 plus negative 1 over x squared dx. And this simplifies into 1 over x to the 4th. Instead of doing a complicated antiderivative, we can just use a comparison test, and we know that the integral of 1 to infinity of 1 over x dx is infinity, which Deatherages, and since 1 over x times square root of 1 plus 1 over x to the 4th is greater than 1 over x, we can determine that 1 over x times square root of 1 plus 1 over x to the 4th Deatherages as well, which is infinite.
The next myth we are testing is the sum of all natural numbers. The presumed answer to the myth is infinity, but we're making sure that that's correct or not. So to start off, you have to use Grandi's series. Grandi's series is 1 minus 1 plus 1 minus 1 plus all the way to infinity. Well, not infinity, but all the way forever and ever. It's an infinite series, just like this one. And we're going to set that equal to g. To solve this, you do 1 minus g, and then that is equal to 1 minus 1 minus 1 plus 1 minus 1 plus 1. When you simplify, it turns into 1 minus 1 plus 1 minus 1 plus 1 minus 1, going on forever. So 1 minus g is equal to g, which means g is equal to 1/2. How does this help? It helps us solving the next series that we need to know. This is another infinite series. We're going to label this one S1 because it does not have a set name. S1 is equal to 1 minus 2 plus 3 minus 4 plus 5 minus 6, going to infinity, alternating. So you can solve this using Abel summation, but we do not have enough time to use Abel summation. It would be too long. But Abel summation is basically integration by parts using different values of this series. A faster way for us to do this series is multiplying it by 2. Multiplying the series by 2 makes it 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus the same thing. But since it's an infinite series, you can shift it over one spot, and it won't change the sum. Since the 1 minus 2, since it all adds up to something, shifting it over is not going to change the sum. When you do that, it turns into Grandi's series, which means that 2s1 is equal to g, and g is equal to 1/2, so s1 is equal to 1/4. So how does this help us? To find our series, we're going to label the sum of all natural numbers as s. And you can set it up as s minus s1. So 1 plus 2 plus 3 plus 4 going to infinity is equal to minus, so 1 minus 2 plus 3 minus 4 is equal to 0 plus 4 plus 0 plus 8. And you can prove that's even farther if I add plus 5 minus 6 plus 5 plus 6. So when you subtract that, it's equal to plus 0. And when you subtract, it changes, so plus 12. So s minus s1 is equal to 4 plus 8 plus 12. And that's 4 times 1 plus 2 plus 3. Well, that's interesting. This is the same series as the sum of all natural numbers. So s minus s1 is equal to 4 times s, because it's 4 on the outside. And since s1 is equal to negative 1 is equal to 1 over 4, s minus 1 over 4 is equal to 4s. Negative 1/4 is equal to 3s, so s is equal to negative 1/12. This means that our myth is busted. It is not equal to infinity. The sum of all natural numbers is equal to negative 1 over 12.